All right, Mr. Kolstad here. Wanted to walk you through the multiple choice portion of the review. We're going to do this video in 5 parts, one for each page. Starting with this first page. First question is asking if the graph of the derivatives are shown above up here in these three, it wants to know which one has a relative max. So remember that when you're looking at the first derivative function, relative maxes and relative mins, we are looking for what we call transition zeros. Transition zeros are where we're going from positive to negative or negative to positive, so that requires us to actually physically strike through the x-axis. You can see that the first function has 2 strike throughs, the second function has 1, and the last function has none, so it's definitely not this one. Now, in order for us to have a relative max, remember that a maximum is like a hill. So we're going to need increase on one side, decrease on the other. And on the first derivative graph, we want to see outputs. So we want outputs that are positive and we want outputs that are negative. You can see that this one is negative to positive. That's a min. This one's positive to negative. So right now this is looking good. This one's negative to positive, so this is a min. So the only graph up here that has a relative maximum would be the first one, which is the letter F. So that would be A. In the second question, we're supposed to look at, again, this derivative graph. This is the derivative graph, and we're supposed to identify which of the 4 statements here are true. And so right off the bat, it says the function is decreasing from -1 to 1. Remember that if we are on the F prime graph, increase and decrease is really looking at outputs. So we're looking at where are the outputs up and where are the outputs down. And so if it's decreasing from -1 to 1, that means we need negative outputs from -1 to 1. That is definitely not the case. You can see up here, because of this is false. So this one's no-go. Next, it says F is increasing from -2 to 0. That would mean positive outputs from -2, positive, 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 positive to 0. Right now, that's looking like it's true. I know you're probably looking at this inequality here and saying that's definitely can't include 0. This is kind of a goofy one. I'll come back to letter B. Right now, this is looking true with a possible question mark at the inequality. If I go to part C, you're going to see that it says that we are positive outputs from 1 to 2. Positive outputs from 1 to 2, that's a no-no. This is definitely not. Those are all negative. A local min at x equals 0. Local is just another word for relative. So remember that when we're dealing with extrema, on a derivative graph, we're actually looking for, again, transition zeros. And we want a transition 0 where we are negative to positive. So we want a valley. Transition zeros. This is a transition 0, but we're positive to negative. So this is actually a max. D is definitely not true. And then you got to be careful with letter E. It says F is not differentiable at these 2 values. Not differentiable would mean it needs a cusp at x equals -1 and +1, but that cusp has to be on f of x, not f prime of x. So you can see that because there's a derivative value at -1, this is not true. Because there's a derivative value at +1, this is not true. So I'm going to go back to letter B. Letter B is the answer to this one. I know you're probably looking at that inequality and you're being picky, but again, if I can clarify, all of these outputs are positive, all of these outputs are positive, and so letter B would be the solution. And then in the last question on page 1, it says to determine the value of A plus B if there's a point of inflection at 2, -2. Remember, points of inflection occur when f double prime of x is equal to 0. So I'm going to drive this twice. Okay, y prime, the first derivative would be 3ax squared minus 12x plus b. That's the first derivative. The second derivative would be 6ax minus 12. This is the second derivative. I can solve for when that is 0, but remember I also know the x coordinate is 2. So again, what I'm going to do is set 6ax minus 12 equal to 0. This is 12a minus 12 equals 0. 12a equals 12, so a is equal to 1. So I know right now for sure that this is a 1. Okay, how do I get b? Well, if I know y is -2, and I know x is 2, and I know a is 1, I've got pretty much every variable except for b. So y equals a x cubed minus 6x squared plus b x minus 4. -2 equals 2 cubed would be 8. This would be minus 24 plus 2b minus 4. I've got a -2 equals this and this will make -16, and a -4 make -20. Put the 20 on the other side. I've got 18 equals 2b, and b equals 9. So if b equals 9, and if you remember, I still have a is equal to 1. That means that a plus b is equal to 1 plus 9, which equals answer D, which is 10.